Hello and welcome back. In this lecture, I just want to go over some common compiler errors and warnings. We talked about some of the common C problems, but sometimes you don't even know you have those errors in your program when the compiler is trying to tell you that. Compiler errors and warnings tend to be really cryptic to new programmers. They may be telling you that you're missing a semicolon, but it says unreachable end of statement. And for somebody new, they might not even know what that means. So it takes a lot of practice in writing a lot of code and to decipher some of these compiler warnings over time. But I'd like to give you a heads up before that. So some of the common problems that you saw in the previous lecture, I'm going to actually describe some of the compiler warnings and errors and what it will actually say. It's very, very important to understand what the compiler is telling you. If the compiler is telling you there's errors, but you don't understand that error, it's going to take you much longer to fix that code. But if you see the error and you know exactly what it's saying, you can then go and fix it in no time. I remember I would be in the lab when I first started programming, and I would be missing a semicolon, something very common. And the compiler would be telling me I'm missing a semicolon, but I wouldn't know that. It would just say unreachable end of statement, and I would be like, what does that mean? What is a statement? I would be very confused. So that's why I wanted to give you some tips on what the compiler is actually trying to tell you. So it's very hard to understand what the compiler is complaining about. To decipher these messages are sometimes very confusing. So you need to understand these compiler errors in order to fix them. Pretty basic. And the compiler is doing half the job for you. It's checking the syntax, telling you exactly what's wrong. So you should use that to your advantage. But sometimes it's difficult to understand exactly what it's saying, especially if you're new and you don't understand some of the terminology. The compiler makes decisions about how to translate your code that the programmer has not written in the code. This is convenient for the program and the compiler so that it can be written more succinctly. And only expert programmers take advantage of this feature. So what I'm telling you is when you compile, you should always use the dash wall option. This is going to turn on everything. So sometimes a more advanced feature is you'll actually take some stuff out, have the translation a little bit more efficient. But when you add that, you cause the program to be compiled differently, and as a result, you may have warnings in your code that you don't know about. So the reason I tell you that is you always want to compile with a certain option, which is the dash wall option. And you actually, by default, that's turned on in code blocks. And this will notify you of all cases where the compiler is doing things that you don't know about. It also will turn on all warnings, give you a lot of information. It's a very useful compiler option. Once you have that option on, then you can try to help you better understand some of what the compiler is telling you. So the compiler is going to show you two types of errors. Or two types of problems. One is an error. This will actually prevent the creation of the program, right? You have a syntax error and the program cannot be compiled. No executable will be created. And usually, I mentioned this earlier, but usually when you see errors from the compiler, you always want to focus on that first error. That's the most reliable error because some of the other errors may be a result of that first error. So always focus on that first error. Fix the errors at the top first and then compile again and see if the other errors go away. Warnings are messages that the compiler shows about for special situations in which some type of anomaly has been detected. They're non-fatal errors, so the executable will be created, but it's still something that you should fix. A warning is there for a reason. You're either doing something incorrectly or it could cause a problem in the future. So you want to always fix all of your warnings. And by compiling with the dash wall option, you do not consider the program correct until all warnings have been eliminated. So the compilation will not fail. This is why I tell you to use this option, as well as seeing everything that's going on by the compiler. So some of the most common compiler messages that you'll encounter, and this will be directly related to some of the most common C problems that we mentioned earlier. If a variable is undeclared, you'll see this message, variable undeclared, first used in this function. This is one of the most common and usually easier to detect. And then it will also display the symbol before this message. It will basically say that you're trying to use this variable, but you never actually declared it. We know that when you declare a variable, you specify the data type. You can't just start assigning data to variables that don't exist. A warning, implicit declaration of function. This is related to the function declarations. It's when you're trying to call a function but the function doesn't have any implementation associated with it. You didn't include the header or you didn't declare it. So it doesn't know where it is, and it doesn't know how the function is declared. It doesn't know the arguments. It doesn't know the return value. It has no information about the function itself. To solve this, always declare a function prototype at the top. Another warning, which is, it will say warning, control reaches end of non-void function. This will happen when a function has been defined as returning a result. It's non-void, but there's no return statement included in the function. So you forgot to return the data. Either the function is incorrectly defined, where you have to remove the data type before the function declaration, or you forgot to add that return statement. One or the other has to be changed in order to fix this warning. But you see how this is a warning. You can still compile it, but man, that could really cause problems in your program if you're expecting a function to return something and it doesn't. So you want to fix your warnings. Unused variable, another common warning. This is printed by the compiler when a variable is declared, but it's never used. You shouldn't be declaring a variable if you don't use it. So remove that declaration. I tend to get these quite a bit when I do some of my demos because I leave in variables that I never use. Or when I was demonstrating how to declare a variable and then I compiled it to show you that I compiled, I would get a warning saying it was never used. So that's okay because I was demonstrating something, but you remove your variables if they're not being used. No need to declare. Undefined reference to. This happens in the linking phase. So remember the compiler or the compilation phase, it will compile. First it will run the preprocessor, then it will compile, it will generate the object files, and then it will take those object files and link them together to make a complete program. So during the linking phase, it needs to resolve any external dependencies, or specifically any functions that you're calling, they need to be implemented somewhere. So if it doesn't have that object file, it's going to give you this problem. You're trying to invoke a function, but we don't have the code for it. So you have to either make sure you link to this file. Usually the linking will happen for you, but in GCC you can just do the -L option to add the linking file. So if you're using a function in the math header file, but you're not linking to the math object file, you're going to get this error. And it also happens if you have user-defined functions and you didn't include a C source file. So you have multiple C source files. One of the C source files is implementing this function. Another C source file is including the header and calling it, but you never compiled the other C source file that has the implementation. You'll see this error. So make sure you bring in that source file. Make sure you bring in any standard library source files if you need to explicitly. Usually you don't have to do that. Another common error, this is when conflicting types. This is when you actually have defined or declared a function prototype, and then when you went to implement it, it wasn't the same as how you declared it. So for example, the prototype has a result type, a name, a parentheses for the parameters, and then a semicolon. And then when you define the implementation, you have a different actual function header. You have a different return type, or you have a different number of parameters. And this is saying, well, hey, you have this one function declaration, and then when you go to implement it down below, it's completely different. So there's a mismatch. And this will actually show you on the line that the conflict appears in the previous definition that caused the contradiction. So in the implementation is usually where it shows you the line, because usually you declare your functions at the top. Runtime errors. Runtime errors are problems in your code that happen when you run the program, not when you compile it. So these are usually crashes, or they're the non-fatal errors where you're array out of bounds or something like that. It's when the program is running, you have some kind of logic error. So the execution of C programs may terminate abruptly with a crash when a runtime error is detected, something it can't handle. There's a memory corruption, like I mentioned. Out of bounds errors usually cause programs to crash. Usually what you'll see is segmentation fault, and segmentation fault doesn't really tell you anything. So typically what you want to do to further diagnose this problem is look at the call stack, as I mentioned, or run a debugger and see what line of call, before the program crashes, stepping line by line to see what line is causing the crash. You can get the call stack if there's a core file, which I mentioned earlier, and then from the call stack you can see what line is crashing. Or better yet, run the debugger, step line by line, and then when you execute a line, you'll see the program crash and you can identify it that way. So these are just, again, some more tips on compiler errors and warnings and messages and how to interpret them. There's actually links online, or if you do a Google, it will tell you every single compiler error and warning that can be produced. And it will actually give a definition of why this was produced it is, and why it was, what was the problem essentially. Because again, those compiler errors can be very cryptic. And if, even the one where it said unreachable control, you never know from that description necessarily, unless you had experience, that means, you never return something from a function. But if you do, one of the best ways to find and fix problems in your program when you have compiler errors and you don't understand that compiler, Google it. And typically what will happen is you'll go to Stack Overflow and it will tell you, hey, this is your error, this is how you solve it. I do that to this day. I've been programming in C for 15 years, but there are still times when I encounter things and I'm like, what exactly does this mean? And I'll Google it. I'll actually take the compiler error, put it in quotes, and it will tell me exactly what's happening. Stack Overflow is a really, really good website. And it can really help save a lot of time in the debugging process. Don't just try to guess when you see compiler errors or warnings. That compiler is trying to tell you something, and it will pinpoint exactly what's going on. So if you understand it, you're going to be able to fix your problem much, much quicker. And if it's not something you're familiar with, go to Stack Overflow or go to a website that describes all of them and you can decipher it that way. I hope this was helpful. Thank you.